this video, we're going to be finding the area of the region bounded by the given equations. We've got a function here, we've got some vertical lines, x equals 0, x equals 3, horizontal line here at y equals 0. Now, I would recommend kind of doing just a rough sketch. All right, obviously we can look at that function and we can see that it's an upside down parabola, but it's going to help us if we know a little bit more than other than just an upside down parabola. So probably I would run the x coordinate at least of the vertex. Okay, so vertex of a parabola, we know that that's a negative b over 2a, so we can run that really quick. All right, so that'll be a negative 3 there, and then 2 times the negative 1, which will give us a positive 3/2. So 1/2, our x value of our vertex is going to be at 1.5. Okay, and really we don't care how high it goes. There's no reason to calculate the y value of that vertex. All right, now it's an upside down parabola. We know that vertex is going to be at like 1.5. Might be nice if we could find the zeros really quickly. All right, so finding those zeros, all we've got to do is basically set the function negative x squared plus 3x equal to 0. We can factor this out pretty easily. So let's go ahead and take out a negative x. If we take out a negative x, we'll have an x minus a 3. Setting this equal to 0, we get x equals 0. Setting this equal to 0, we'll get x equals 3. So then that gives us, where the parabola is crossing the x-axis, and we know that vertex is like, 1.5 there, so halfway in between. So now I can do a pretty accurate rough sketch here. All right, so we got intercepts at 0, intercepts at 3, 1.5 here, and it doesn't matter how high it is, okay? We'll just like randomly put it there. Okay, so upside down parabola, right there. There we go. Now we've got a vertical line here at, let's switch to a different color. We've got a vertical line here that's bounding at 0. We got a boundary at x equals 3, and we've got a boundary at y equals 0. All right, so then that gives us a really clear picture there of what we're trying to do. We're trying to find the area of that region right there. Okay, now to actually then find that area, we're going to use integration. We are going to integrate the functions in terms of x, so we want limits of integration for x, so we're going to integrate from 0 to 3 of that negative x squared plus 3x. We're integrating that function on the interval from 0 to 3 with the dx there. Now this is going to be a straight integration here. It's just a nice little polynomial curve. When we integrate this negative x squared, adding 1 to that exponent there, adding 1 to the exponent, we'll have an x to the third. That'll give us a negative 1/3 in front. The plus will come straight down. Adding 1 to the exponent here, we'll have an x squared. That'll give us a 3/2 right here. Okay, so there's our integration. Now we want to evaluate from 0 to 3. Okay, plugging in 3 here, we're going to have a negative 1/3 times 3 to the third plus 3/2. Plugging in the 3 again, we'll have a 3 squared. Okay, all of that. All right, and then minus, well, we're going to plug in 0, which will make this 0. We're going to plug 0 in here, make that 0. So 0 plus 0, so we're going to be subtracting 0 there. All right, doing a little math here, that's going to be a 27 divided by 3, so we'll get a negative 9 right here. Working this out, we're going to get a 27 over 2, it looks like. Going ahead and putting that together, we'll just have a straight 9/2. All right, so finding the area of the region bounded by the given equations, we've got a simple 9/2 there. So a pretty straightforward beginning problem where you're finding that area under the curve. All right, nowhere in the question did they say you had to sketch it. All right, but sometimes just having a visual, doing just a little bit of math to get a fairly accurate sketch will definitely help you set up that definite integral and know exactly what you are doing and what you're seeing. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.